Workbook 13.1 uses Pythagorean's theorem and then special right triangles. So number 1, it says students measure the sides of 4 triangles in a test. The lengths of the sides of the different triangles follow. So triangle 1 is 6, 12, and 13. Triangle 2 is 5, 12, and 13. Triangle 3 is 3, 4, and 5. And then triangle 4 is 2, 4, and 6. Workbook 13 goes over Pythagorean's theorem and then also special right triangles. So number 1 says students measure the sides of 4 triangles in a test. The lengths of the sides of the different triangles follow. So triangle 1 was 6, 12, and 13. Triangle 2 had sides 5, 12, and 13. Triangle 3 was 3, 4, 5. And then triangle 4 had side lengths of 2, 4, and 6. It says using the Pythagorean theorem, which triangles are right triangles? So in order to confirm that they're right triangles, you just have to make sure that they satisfy the Pythagorean theorem. So just one thing to remember with Pythagorean's theorem, if it's a right triangle, it has 2 legs and then a hypotenuse, and the hypotenuse is always the longest side of the triangle. It's across from the right angle. That's always going to be C. So if we look at like all of these triangles that are listed here, all of the longest sides, those have to go in for C. And then the shorter sides would go in for A and B, and that order doesn't matter. So I'm going to start with triangle 1. So triangle 1, we'll start with A squared plus B squared equals C squared. The hypotenuse of triangle 1 was 13, so we'll put that in for C. And then the legs were 6 and 12, so those will go in for A and B. And like I said, that order doesn't really matter. So it'll be 6 squared plus 12 squared equals 13 squared. And then we'll square each one separately. So 6 squared is 36, plus 12 squared is 144, and then equals 13 squared, which is 169. And then we'll go ahead and add up the 36 plus 144. So it should be 180 equals 169. And of course, like that's not true. So that would mean that it's not a right triangle. If it were true, that would confirm that it's a right triangle. And then triangle number 2, I'm just going to copy this over. But we'll approach it the same exact way. So all 4 triangles will check the same way. For triangle 2, one leg is 5, one leg is 12, and then one leg, or not leg, but the hypotenuse is 13. So it would be 5 squared plus 12, nope, sorry, plus, oh yeah, it was 12 squared, plus 12 squared equals 13 squared. 5 squared is 25, plus 12 squared is 144, equals 13 squared is 169. And then 25 plus 144 is 169. So we end up with 169 equals 169. So that's true. So that means that that triangle is a right triangle because it satisfied Pythagorean's theorem. So triangle 2 would be one of them. And then we'll check triangle 3. So for triangle 3, we have a leg that's 3, a leg of 4, and the hypotenuse is 5. So it'd be 3 squared plus 4 squared equals 5 squared. 3 squared is 9, plus 4 squared is 16, equals 25 squared, sorry, getting ahead of myself, equals 5 squared is 25. And then 9 plus 16 is 25. And then we have 25 equals 25, so that one does satisfy Pythagorean's theorem. So triangle number 3 would also be a right triangle. And then we'll check number 4, so we just need to figure out, like, of all of them, which ones are. So triangle number 4. So we have a leg of 2, another leg that's 4, and then the hypotenuse is 6. So it'd be 2 squared plus 4 squared equals 6 squared. So 2 squared is 4, plus 4 squared is 16, plus 6 squared is, I keep saying plus, equals 6 squared, which is 36. 4 and 16 is 20, and then we have 20 equals 36, which of course that's not true. So that would mean that triangle 4 is not a right triangle. So to determine if any triangle is a right triangle, you take the legs and the hypotenuse and put it into the Pythagorean theorem, and if it makes the equation true at the end, it would confirm that it's a right triangle, and if it's not true, it's not a right triangle. And then just remember that the longest side of the triangle has to go in for C because that's the hypotenuse. So number 2, an architectural firm wants to replicate a nearby estate with some changes. The new estate will be larger than the original by a scale factor of 1 to 10. A section of the roof of the original estate can be or is constructed using 45, 45, 90 triangles. The hypotenuse of that triangle is 10 meters long. So that means that the hypotenuse of the original roof, or the diagonal of that original roof line, is going to be 10 meters long. And we want to find the length of the legs of the larger estate. So we actually need to find first the hypotenuse of the larger estate. This order you can switch a little bit, but I think we'll go ahead and just find the hypotenuse of the larger estate. And this was a scale factor of 10. So that means that if we multiply our original hypotenuse by 10, we'll get our new hypotenuse. So we'll take that 10 meters, multiply by 10, and that's going to give us 100 meters over here. So that would be the length of the hypotenuse of the roof portion on the new estate. And then they said that this roof was constructed using 45, 45, 90 triangles. So no matter how much I change the scale by, so if I multiply by 10, multiply by 20, whatever it may be, it's going to stay proportional. So it's still going to be a 45 or 45, 90 triangle, it's just going to be bigger. So when you have a 45, 45, 90, the ratio that we can use to represent the legs are going to be x and x. And remember, the legs are the non-hypotenuse side. So this is my right angle. The hypotenuse would be the 100, and those two smaller sides would be the x's. And then the ratio that goes with the hypotenuse is x root 2. So what I recommend doing for a problem like this is whatever side you are given, set it equal to the ratio that goes with that side. So for example, we're given 100. So I'm going to set that equal to x root 2. So I do x root 2 equals 100. And then now I'm going to solve that equation for x, and that x is going to be the same as these x's. So it's actually going to give us the length of the legs, which is what we're trying to find. So I would solve them using how we'd solve any other equation. So in this case, root 2 is being multiplied by the x. So I would divide both sides by root 2. Root 2 divided by root 2 cancels out, and then I'd be left with just x equals, and then 100 divided by root 2, I'm just going to go to a calculator for that, so do 100, and then divided by the square root of 2, ends up being 70.71, or approximately 70.71. So we could say x is approximately 70.71, and then this was in meters. So this answer ends up being A. So approximately 70.71 meters is going to be the that section of the roof on the new estate, the one that's been expanded. So I think technically, and I could double check it really quick, I guess instead of just thinking, you should be able to apply the scale factor after. I just kind of want to double check for your guys' sake. Sorry, it's in the video. So if I didn't apply the scale factor first, I would be just working off the smaller triangle here, but the ratios would be the same. So it'd be x, oops, not that. It'd be x root 2, and then instead of setting 100 equal to x root 2, I would do x root 2 equals 10, and then I would go over to my calculator, and I would do 10 divided by root 2. And so that gives us 7.071, and then after we would multiply by the scale factor, which is 10, so we'd move the decimal place once to the right, so you'd end up getting the same answer. You'd get 70.71 if you waited to apply the scale factor until the very end. So I guess personal preference for a problem like this. Most of the problems, I will say, it's kind of helpful to just apply it at the beginning, especially if you're dealing with volume and stuff like that. Okay, so number 3, a snail farmer's business is growing. He wants to build a new pen similar to the old one, but with a scale factor of 1 to 3. So this will accommodate his expanding business, and the old pen is square. So if the diagonal of the old pen measures 10 meters, what's the length of one side of the new pen? Use Pythagorean's theorem. So if the old pen is a square and the length of its diagonal is 10 meters, that means that when he creates his new pen, with a scale factor of 1 to 3, that means we have to take that 10 meter diagonal and we just need to multiply it by 3 to get the length of the new diagonal, so it'd be 30. So it'd be 30 meters. Use Pythagorean's theorem here, which you can technically use a 45, 90 triangle here as well, kind of like we did with number 2. So the reason being is like the diagonal cuts the square into like 2 equal triangles, right? 2 of the triangles are the same size, so that's a right angle. This was a right angle, but it got cut in half, so now it's 45, and so is this, it's also 45. So if you wanted to use special right triangles, you would approach it the same way. So like this would be, like the 2 legs would be x and x, and then this would be x root 2. So I'm gonna just erase the smaller square so I have some more room to work. So what I would do is I would take that 30 meters and I would set it equal to my x root 2 equals 30. And then from there, I'm trying to solve for x. I'm trying to get x by itself. So I would divide both sides by root 2. Divide both sides by root 2. These cancel out, and then I'd be left with x equals, and I'll go over to the calculator to do 30 divided by root 2. So 30 divided by root 2 is approximately 21.21. So x is approximately 21.21. This would be in meters, and that would be for both legs, like 21.21. This would also be 21.21, because when you have a 45, 45, 90 triangle, it's an isosceles triangle, so the 2 legs are the same lengths. So this would end up being C. In the problem, like it says use Pythagorean theorem, I would personally probably never use that method, but just for the sake of following the directions, we'll see what it looks like. So I don't think I've literally ever done a problem this way, but when we have a 45, 45, 90, so just kind of bear with me. Okay, so Pythagorean's theorem, a squared plus b squared equals c squared. So we know that c is the hypotenuse, right? I don't really need, I'll leave those up there. But we know that c is the hypotenuse, and in this case, that's 30. So I'll go ahead and put 30 in for c. So it'd be 30 squared. And then we don't know either of the legs, but what we do know is we know that they're the same. Because if it's a 45, 45, 90, those 2 45-degree angles means that the 2 legs are also congruent. So we know that A and B have the same value. So I'm just going to go ahead and put the same variable in for each one, and I'm just going to use these x's. You can use any of the same variable, but it'd be x squared plus x squared equals 30 squared. And then now we want to solve for x. So for solving, we want to make sure that each side of the equation is like simplified before we start to use inverse operations to isolate x. So that would mean adding these 2 together, because they're technically like terms because they both have x squared. So you would add them together by adding the coefficients. And remember, if there's no number in front of the x, it would be like a 1. So 1x squared plus 1x squared would give us 2x squared. And then over there, 30 squared, we can go ahead and square that, would be 900. And then now I'm trying to get x completely by itself at this point, because the left side of both sides of the equal sign are simplified. So what I would do is I would go ahead and divide both sides by 2 first to cancel out the 2 that's being multiplied by the x. I wouldn't want to like square root first. I would not want to do this because it would just be a pain, like you have to square root the 2 as well. So I'll go ahead and just divide both sides by 2. That'll leave me with x squared equals 900 divided by 2, which is 450. And then from there, I need to go ahead and take the square root of both sides to get x completely by itself. That cancels out the power, and then we'll go to the calculator for the square root of 450. So square root of 450 ends up being about 21.21. So we end up with the same answer. Like I said, it probably won't, maybe use that one more than, I don't know, it depends what you're more comfortable with. You're more comfortable with like Pythagorean's theorem or special right triangles. So either way. So x is approximately 21.21 meters, and then like I said, it's just the same answer we got using the other method, so it's totally up to you.